in this video we'll be focusing on geometric sequences. What is a geometric sequences? Here's the definition. Is a sequence where the ratio of any two consecutive terms is constant or it's common, or I like to use the word constant. It's common or it is constant, right? Okay, so what do we mean by that? That the pattern, the consecutive terms are constant. The ratio of the consecutive terms are constant. Okay, let's take a look at this example that I'm going to give you. We have the pattern 3, 12, and 48. Right? What do we mean by that? Okay, so the ratio of two consecutive terms, it must be constant. How do we get the ratio? The ratio is represented by R. How do we get the ratio? We're going to say, okay, we're going to say T2 divided by T1. Right? In this case, we'll have 12 divided by 3, and then that will be 4. Okay, so but by doing that, we cannot say the ratio it is common or it is constant. Okay, so now to check again, we're going to say T3 divided by T2. Then we go forward, and then what is our T3? Our T3 is 48, and then we divide it by 12, which is our T2. It's term number 2, and then that is also 4. Therefore, now we can say this pattern, it's a geometric sequence because the ratio between two consecutive terms are common. As we can see, they are common. Here it's 4 and it's 4. And what are those consecutive terms? It's T3, T2, it's T3, and then T2. You can see them, and then it's T2 and T1, the consecutive terms. So they are common. So now we can conclude that this is a geometric sequences. Okay, so now in geometric sequence we have the formulae which is defined. The quadratic sequence is defined by Tn is equals to a r n to the power n minus 1. And then what is n? We have explained n. N is the position of the term. What do we mean by the position of the term? 3, it's in position 1. Therefore, when it's in position 1, our n will be equals to 1. How do we represent it? We're going to say term number 1 is equals to 3. That's how you represent it. Okay, so now what is the meaning of a? What does a mean, and what is a? A is the first term of the geometric sequence, and the first term of geometric sequence, it's T1. And what is T1 equal to? T1 is equals to 3. I'll say 3, right? So that is our a. And then how do we get the common ratio? The ratio, we already found it. It's R, it's equals to 4 from above there, our constant ratio, right? Okay, so now how do we represent the nth term for the geometric? Now we'll say nth term, and then we'll say Tn is equals to AR n to the power, and then what is our Tn is equals to, what is our a? Our a is equals to T1, which is 3, and then our r it is 4, and then we close the bracket n to the power there, and then this is our nth term for geometric sequences. That's how we represent it. Okay, now let's take one example. Let's go through an example of a geometric sequence. Given a geometric sequence, given a geometric sequence 36, we have 36. Oops, it's not ready. 36 minus 18. 9. Right, so now what is the constant ratio of our geometric sequence? What is our constant ratio? We're gonna say 18, which is the second term, divided by 36. What is 18 divided by 36? That will be negative, it's negative 18, right? That will be negative 1 over 2. And then 9 divided by minus 18, that is also minus negative 1 over 2, right? Okay, so now we know that it's a geometric sequence because we have also shown that the ratio between consecutive terms is constant. So now let's attempt the question. We have 2.2.1 and determine the value of r, the common ratio. R is equals to negative 1 over 2, and then you have answered the question, negative 1 over 2. Okay, now let's see. We go to 2.2.2, and then what is our calculate n if Tn is equals to 9 over 4096. Okay, our Tn, our general formula for the nth term, we know that it's Tn is equals to Arn minus 1. And then we are told that it's equals to what? It's equals to 9 divided by 4096, right? Okay, so now when looking for the value of n, we're looking for the value of n. Okay, so what is our a in this case? Our a is the first term of the geometric sequence, and our first term of the geometric sequence, it's 36, and then our r, it's minus 1 over 2, and then we'll have n to the power n minus 1. That will be equals to 9 over 4096, right? Okay, let's move on. Now we're going to divide both sides by 36. We divide this side by 36. We divide both this side by 36, right? Okay, and then this 36 divide this 36. That will be 1, and then we're gonna say 1 over is gonna be negative 1 over 2 to the power n minus 1, and then that will be equals to our left hand side dividing 9 over 4096 by 36. That will be 1 over 163.84. Am I right? Yes. And then now we'll have to change our 163 so that it can be the same as our left hand side, so that we can apply law of exponent. Okay, that will be, we'll have negative 1 over 2 to the power n minus 1, which is equals to 1 over 2 to the power of 14, right? 2 to the power of 14, that is 163.84. Okay, so it's the same as what? It will be the same as 1 over 2 into the power of n minus 1, which is equals to 1 over 2 to the power of 14. But then now in this case, our left hand side, the base at the left hand side, it's not the same as the base at the right hand side. So now what are we going to do? Okay, now, okay, look at up there. Negative 1 over 2 to the power of 14 is the same as 1 over 2 to the power of 14, right? Yes, it's the same as negative 2 squared, which is equals to 2 squared, which is equals to 4. So they're both the same. So in this case, we're going to introduce negative so that, we're going to introduce negative so that our base can be the same, and then move forward. Then our base are the same. Then we'll have n minus 1 equals to 14, and then our n will be equals to 15. Then you go to get your 3 marks. You go to university of your choice. Thank you.